System of equations, Part B. Elimination method. Choose one of the variables to keep, then eliminate all the others. So you want to keep one of the variables, then eliminate the others to know the value of this variable. Exercise 1. Find the values of x and y. Let's say we have linear equation A and linear equation B. Linear equation A has 5x plus 3y equal 8, and linear equation B is 10x minus 3y equals 7. Okay, we need to eliminate one of these variables. Either it's x or y. So the easiest variable to eliminate here is y, as we have here positive 3y and negative 3y. So we can add these two equations. So we can add them. So by adding the x, we have 5 plus 10x, so it's 15x. Then positive 3y minus 3y, it will be 0y. Then the 8 and the 7 plus each other, it will be 15. So we have 15x plus 15. We can remove this 0y. So we have 15x equal 15. So the x will be equal to 15 over 15. So the x is equal to 1. Okay. We have successfully got one of the variables. We can now substitute in any of these two equations, either it's LA or LB, to know the value of y. Okay, let's substitute to find y, substitute with any of the equations with the value of x. Okay, so we substitute in LA. So we have LA 5x plus 3y equal 8. We know the value of x is 1. So we have 5 times 1 plus 3y equal 8. So it's the same as 5 plus 3y equal 8. So we send the 5 to the other side to be negative 5. So 3y will be equal to 8 minus 5. So 3y equals 3. So the y will be equal 3 divided 3. So the y is equal to 1. Okay, we have successfully got the x value and the y value. Now to check the solution, try the x and y in LB, this equation. Okay, so we have got the x with 1 and y with 1. Okay, so we have 10x minus 3y equals 7. We'll get here 10 multiply 1 minus 3 multiply 1 equals 7, and the x is 1 and the y is 1. Okay, so it's 10 minus 3 equals 7, so it's 7 equals 7, so it's correct. Exercise 2. Find the values of x and y. Now we have two equations, 2x plus 5y equal 11 and 3x minus 5y equal 4. So it will be easy to remove the y just by adding the two equations. So we can add them, and also you can subtract the equations. You can add or subtract, but I prefer this method. Okay, so we have 2x plus 3x, it will be 5x. Then positive 5y minus 5y, it will be 0y. And 11 plus 4 will be 15. So we have 5x. We can remove this 0y. So we have 5x equal 15. So we can send the 5 to the other side by divide. So you'll have x equal 15 divided 5. So x will be equal to 3. Okay. Now we can substitute in any of these two equations, whether it's LA or LB. So let's substitute in LA with x equal 3. So let's write LA again here. We have 2x plus 5y equal 11. Let's substitute with 3, the value we got here. So we have 2 times 3 plus 5y equal 11. 2 times 3 is 6 plus 5y equal 11. Send the 6 to the other side to be 5y equal 11 minus 6. So 5y will be equal to 5. To get the value of y, divide 5. Send the 5 to the other side by divide. So we have y equal 5 over 5. So y is equal to 1. Okay, to check the solution, try x and y in LB. Okay, but why do we try in LB? Because we already applied that in LA. We got the value of x equal 3 in LA to get the y. So we should try a different equation. Okay, we got the x equal 3 and the y equal 1. Let's try it again. Here we have 3x minus 5y equal 4. Let's substitute by the values here, 3 and 1. So we have 3 times 3 minus 5 times 1 equal 4. So 3 times 3 is 9, and 5 times 1, of course, will remain 5 equal 4. So 9 minus 5 will be 4. So 4 is equal to 4, and our solution is correct. Okay, exercise 3. We have here LA 3x minus y equal 23 and 4x plus 3y equal 48. Okay, by adding these two equations, you won't get rid of any of the variables. So the best thing to do here is multiply any of the equations with any value. So I see here, if we make the coefficient of y negative 3, we will be able to get rid of y. So we can multiply this equation by 3, so it will be 9x. But we can also multiply 4 to this equation and 3 to this equation. We have 4 times 3 is 12, and 3 times 4 is 12, and subtract them. But I prefer the first method. So you will multiply the first equation by 3 because it's more time efficient. So we multiply 3 to each of them. 3 times 3 and minus 3y equal 23 times 3. So it will be 9x minus 3y equals 69. Now they are ready for addition. You will get rid of y easily now. Now you will add them. So 9x plus 4x will be 13x, and negative 3y plus 3y will be 0y, then 69 plus 48, it will be 117. So we can remove this 0y, so we have 13x equal 117, send the 3 to the other side by divide, so we have 117 divided 13, so the x is equal to 9. Okay. Now we can substitute in LC. Now it's LC because we multiplied it. I call this equation LC. Okay, so in LC we have 9x minus 3y equals 69. We got the x equal 9. Let's substitute with 9. So we have 9 times 9 minus 3y equals 69. So we have 89 minus 3y equals 69. So we can send the 81 to the other side by divide. So we have negative 69, negative 3y equal 69 minus 81. So we have negative 3y equal negative 12. We can send the negative 3 by divide to the other side. So we have y equal negative 12 divided negative 3. So we have y equal 4. Okay, to check, you will try x and y in LB. Okay, remember we got x equal 9 and y equal 4. So we have 4x plus 3y equal 48. So 4 times 9 plus 3 times 4 equals 48. So we have 36 plus 12 equal 48. And 36 plus 12 equal 48. So 48 is equal to 48. Then we have got it right. Exercise 4. Find the value of x and y. We have LA, negative 4x plus 8y equal 9, and LB, x minus 2y equal 3. Okay, the best thing to do here is to multiply LB by 4, so we can get rid of x. It will be very easy to get rid of x like that. So multiply the LB by 4. So we have 4 multiply the x minus 2 times 4, y equal 3 times 4. They will be 4 minus 8y equal 12. Okay, now we are ready to add them. So negative 4x and 4x, it will be 0x, positive 8y and negative 8y, it will be 0y, and 9 plus 12 is 21. So it's 0 equal 21. It can't be possible. So what is that? It can't be right. Okay, this equation have no solution as LA and LB are parallel. Remember the previous session? I said that if LA and LB have no solution, then they are parallel. They won't intersect at any point. You see here, the two lines can't intersect because they are parallel to each other. Exercise 5. Find the value of m and n. Yes, don't get confused. Maybe it's x and y, m and n, o and p, q and r, whatever, They're any variables, they will be easy to solve. Don't get confused. Just imagine they are x and y, Okay, now we have negative 3n minus 9n equals 66. And the other equation is 4n equals 7m plus 71. But can you see now they are not arranged properly? So we'll need to get the 7n in the other side. So we'll transfer it. It will be negative 7m and keep the 71 like that. So it will be negative 7m plus 4n equals 71. And keep every variable under the variable, beneath the variable, in the other equation, so they can be added properly. Okay, and make sure that they are in the right side of the equation. I don't mean right, no, I mean in the correct side of the equation. So if we have 4n, if you want it to be in the other side, it will be negative 4n. Don't get confused, okay? Okay. Now we have negative 3 and negative 7, negative 9 and 4. So we can't solve this by one multiplication only. We will need to multiply the two equations. Whether we multiply that both by 9, this equation by 9 and this equation by 4, or we can multiply this equation by 3 and this equation by negative 7, so we can eliminate the m or n. Okay, so let's multiply this equation by 7, okay, and this equation by negative 3. So we will eliminate the m this time. Okay, so we'll multiply the first equation by 7 and the second equation by negative 3. So we will have the same coefficient in m. So we can eliminate it easily. So we will have negative 21m and minus 63n equal 462. And we will have negative 3 times negative 7. Remember, the negative will cancel out each other, and 4 times negative 3 and 71 times negative 3. So they will be 21m minus 12n equal negative 213. Okay, so we can eliminate the m with the m. So after adding them, we will have 0m, and negative 63 minus 12n, it will be negative 75n equal negative 249. So to get the value of n, send the negative 75 by divide to the other side. So the n will be equal to 149 divided negative 75. So the n will be equal to negative 3.32. Okay, we will substitute by this value in equation 3 here. So we have here 21m minus 63 and negative 3.32 instead of n equal 46. So after multiplying 63 and negative 63 and negative 3.32, the value will be negative 21m plus 209.16 equal 462. You will send this to the other side, 209.16. So we have negative 21m equal 462 minus 209.16. So we have negative 21m equal to 152.84. So send the negative 21 by divide to the other side. So we will have m equal 12.04. Okay, we got the m and n. You can check if you want. Exercise 6. Find the value of r and s. Okay, it's the same here. this equation need to be rearranged. We can send the s to the other side here, so it will be 5r plus 9s, and send the 6 to the other side, so it will be negative 6. So we have here 5r plus 9x equal negative 6. Okay. We also will need to, apply 2 multiplication to be able to solve this equation. So you'll multiply the first equation by 5 and the second equation by negative 3 to get here the same coefficients in r, and with the additive inverse in equation 2. So we have 5 times 3 and 4 times 5 s equal 2 times 5, and here also we multiply negative 3. So we have negative 3 times 5 and 9 times negative 3 and 6 times negative 3. So the first equation will be 15r plus 20s equal 10, and the second equation is negative 3 times 5r, it will be negative 15r minus 27s equal 18. So now we can cancel out the r with each other after adding. So 15 and negative 15 will be 0r, and 20 minus 27 we will have negative 7s, and it will be equal to 28. So we can remove the 0r, you don't need it. Okay, we have negative 7s equal 28, so we can send it to the other side by divide. So we have s equal 28 divided negative 7, so it will be negative 4. Okay, so we can calculate it in equation 3. So we have here 15r equal 20 plus 20 multiply negative 4 equal 10. So after multiplying the 20 and negative 4, it will be negative 80. So we can send the 80 to the other side. So we have 15r equal 10 plus 80. So we have 15r equal 90. So we can send the 15 to the other side by divide. So we have r equal 90 divided 15. So r will be equal to 6. Solving 3 variable equations by substitution. Okay, work to generate 2 equations with 2 variables only. It means that we will work in eliminating one variable and keep these 2 equations without this variable. Okay, then solve them normally to get their values, okay, or the value of their variables, Then after that you can just substitute with the first equation, Just imagine that there are 3 villains, okay? The 3 equations are 3 villains and you need to beat them. You get one of them, then you can get the other, then you can get the other. Okay, let's see an example here. It will be easier with an example. Okay, exercise 7. Find the value of k, v, and w. Okay, we have equation 1, k plus v plus w equals 6, and equation 2, 2k plus v minus w equal 1, and equation 3, 3k minus v plus 2w equals 7. Okay, let's think here. We can eliminate one of the values. Let's see here, we can work with these 2 equations, equation 2 and equation 3. Okay, let's add them, equation 2 and equation 3. You can get rid of the v. Okay, so we have 2 plus 3k, it will be 5k, and positive v and the negative v, it will be 0 v, and negative w and 2w, it will be w, then 1 and 7, it will be equal to 8. Okay, we can remove this 0 v, we don't need it anymore, then we'll call this equation 4. Okay, let's see here, where also can we remove the v? Even if you couldn't remove it directly, we can multiply both equations as you remember, so don't worry about it. So we can use equation 1 and equation 3. We can add them together. We can get rid of the v again. So you have here equation 1 and equation 3. We have here k plus v plus w equals 6 and 3k minus v plus 2w equals 7. So when we add them, we have k and 3k, it's 4k, and positive v and negative v. They will cancel out each other. It will be 0v and w, and 2w, it will be 3w. Then the 6 and 7 plus each other, it will be 13. Okay, we can get rid of this 0v. Then we have equation 5. Okay, so we can work with equation 4 and equation 5 to get the value of whether the w or the k. We can get one of them now. It's easy. Okay, so we have equation 4, 5k plus w equal 8, and 4k plus 3w equal 13. Okay, let's see here. Maybe we can multiply the first equation by negative 3 to get rid of the 3w here. So we'll multiply it by negative 3. Okay, so you have negative 3 times 5k plus w times negative 3 equal negative 3 times 8. We'll have negative 15k minus 3w equal negative 24. You see here, negative 3w and positive 3w. We can add them now. So we'll have negative 11k and 0w equal negative 11. We can remove this 0w. We don't need it anymore. We can just send the negative 11 by divide to the other side. So we have k equal negative 11 divided negative 11. So we have k equal to 1. We can take this k and apply it to equation 5, to get the value of w. So remove the k and put 1. So we have 4 times 1 plus 3w equal 13. So we have 4 plus 3w equal 13. So we can put 4 to the other side. So we have 3w equal 13 minus 4. So we have 3w equal 9. So we can make w, send the 3 to the other side. So we have 9 divided 3. So the w is equal to 3. Okay, we got the k and the w. The only one left is the v. We can take this 3 and the 1 and apply it to any other equation. Let's erase this place. Let's apply it to equation 1. Okay, it seems easy. Okay, let's take equation 1. Let's write it again. K equal 1 and w equal 3. K plus v plus w equals 6. You will put the k with 1 and w with 3 and add them here. So we have v plus 4 equals 6. So we can send the 4 to the other side. So we have v equals 6 minus 4. So v will be equal to 2. Here you get them. The k is equal to 1 and the w equal 3 and v is equal to 2. Okay, the homework here, find the value of m, n, and p, these three equations, and write them in the comments section below. Okay, we have done the elimination. What's left now is a substitution. And we are done with the graphical. And we're still not done yet with the substitution and the matrix.